Hi everyone, myself Dr. Oliver. In this video, I am going to discuss about cascading circuit for trap signal. It is under Automation and Control System Laboratory. So last video we discussed about sequencing of two cylinder with a sequence of A plus, B plus, A minus, B minus. And in this video, we are going to see the new circuit A plus, B plus, B minus, A minus. So if you are having practical applications. For example, we are going to drill a hole. First, you have to clamp the workpiece, so A plus. Then you have to drill the workpiece, so B plus. Afterwards, you can't go like earlier sequence. Uh, we have to retract first the drill bit, then we have to retract or declamp the workpiece. Okay, so it's a practical difficulty. So what will happen if you follow the same as earlier means we will get the fighting signal. To avoid that, we are going for a new method, cascading, to get the solution. So we'll see one by one. So what is our task? We have to construct the pneumatic circuit for trapped signal using cascade method. So like earlier, we need all the hardwares, flow control valve, FRL unit, 5 by 2 direction control valve, double acting cylinders, two double acting cylinders, two 5 by 2 direction control valve, then 3 by 2 roller operated limit switches, each two, so four limit switches we need, then connectors. So finally we are going to execute or simulate this in Presto Fluid Sim software version 6. So before entering into that, we discuss about what do we mean by cascading circuit. Okay, so we heard about logic circuits. So the logic circuits you can classify in sequential and combinational circuits. What is a combinational circuit? In combination circuit, each binary output is a function of only the present. Based on the present inputs only, we are getting the output. Okay. Sequentially, all the outputs are dependent on the previous outputs. In sequence only it works. Combination means only the present input they will consider, and it will give the output. So sequential circuits based on the previous input, it will give the output. This sequence circuit we can divide it into asynchronous and synchronous circuit. What do you mean asynchronous? It is event-based circuit, which means that a step occurs only after the previous step is successfully completed. Before completing the previous step, it won't move to the next. First, it has to get the signal about the completion of the previous action, then only it will proceed for the next action. Okay. Then synchronous circuits are time-based. The system is driven by a cloud producing pulses, and each pulse triggers a step. So time-based means it won't consider the event, whether it is completed or not. Immediately it will close the door. So actually the person has to move out, then only you have to close the door. But within a short while, or 2 minutes or 3 minutes, no one is moving out, it itself complete the action. Or the job is available in that location or not, it will move. So it is a synchronous circuit. Schematic circuits can be designed in various methods. So if there are fighting signal, we can solve it by using various methods. But there is no such universal method to design this circuit. There are 5 different methods various industries are following. One is classic method, cascading method, step counter method, logic design method with Karnavis maths, and combinational circuit diagram. But in general, most of the industries they will follow cascading method. More cylinders we have, complicated circuits around, we can go for logic design method. So what is a cascade? It's a technique used to give sequential circuits by switching on and off the air supply to walls in the groups. We are going to get the air supply So it's a technique used to give sequential circuit by switching on and off of the air supply towards them. For that purpose only, we need this cascade. That involves how it will proceed that one. It involves the dividing the sequence into two groups. First, it divides the sequence into two groups, which each group manifold being supplied with pneumatic power one at a time and in sequence. So now I understand what you mean cascade. So cascade, which helps you to find the sequence and it guide you to switch on the supply at a sequentially manner. So there are some rules to construct this cascade circuit. One is first you have to establish the correct sequence. So for example, in our example, we have a sequence of A plus, B plus, B minus, A minus, B minus, A minus, not A minus B. So in the sequencing, A plus, B plus, A minus, B minus. Here A plus, B plus, B minus, A minus. Now we have to divide this sequence into groups. So no letters repeated within any group. For example, A plus and A minus, we can't keep it in the same group. Similarly, B plus and B minus, we can't keep it in the same group. So always start a sequence with run or end valve selecting group 1. Okay. Run or end valve selecting. Always start a sequence with run or end. For example, A plus, B plus, then B minus, A minus, C plus, C minus. So I am going to divide. So we can start with C minus, A plus, B plus, B minus, A minus, C plus. Okay. For each cylinder, assign 5/2 valves or 4/2 directional valve without spring return and 2 spring return 3/2 limit sets to indicate the end of the step. Okay. Assign one or more group valves or cascade valves to control the air pressure to the group manifold line so that only one group manifold line is pressurized at any one time and in sequence. Cascade valves for 2, 3 and 4 groups. For example, first one group, two group, three group and four groups are output of manifold. For example, how many control lines we need? For example, uh, there are two cylinder cascading circuit needs. We need double the cylinder limit sets equal to 2 into 2. So 4 limit switches we need. There are two groups means two group lines we need. Two group lines we need. So number of group equal to number of group lines. Likewise, number of group valve equal to number of group minus 1. So here two groups, so one group valve. Number of cylinders equal to number of direction control valve equal to number of cylinders. Number of limit switches equal to double the number of cylinders. Okay, please remember all these points while designing a cascading circuit. So some of the instruction, the first function in each group is signaled directly by that group only. The last trip valve operated in each group is supplied with main supply air and selects the next group. The remaining trip valves are supplied with air from their respective groups and initiate the next function. The run or end valve will control the signal from the last trip valve to be operated. Run or end valve will be control the signal from the last trip valve to be operated. So now you can see the normal sequence, how it will be. For example, when we are push button switch on, what will happen? Extension by cylinder 1, then extension of cylinder 2, then retraction of cylinder 1, then retraction. So it's a sequence what we discussed in the last video. Here we have that group of A plus, B plus, B minus, A minus. So how we can group it? The same letter we can't keep it in the same. So A plus, B plus, then B minus. So we can't go there. So we can go for, so two groups you can form. So A plus, B plus in group 1 and B minus, A minus in group 2. So cascade valve or group valve, if all say it's a direction valve 5 by 2 double pressure operated valves or double pilot operated valves. So it's a circuit. We have two groups: cylinder one, cylinder two. Then this limit switch 1, limit switch 2, limit switch 3, 4, then group this one direction control valve 1, direction control valve 2, the group valve 1, FRL unit, compressor, and these are all power lines or group lines. We call as a group lines. Okay. So you can see when push button is there, immediately it takes supply from the group 1, action continues. So supply the extension access. Now we are getting the signal. So double this one direction of the valve 2 actuates and extension access in cylinder B. Now from there we are getting the signal to group valve. We are changing the group from A to B. Immediately retraction occurs in cylinder B and in cylinder A. Okay, so these are all the sequential gates. The flow line you can see in this view how the flow line will be. Extension occurs. Immediately B minus, so B minus, A minus. Okay, so based on this, we are going to draw a circuit using fluid sim software and we will simulate that and we will check it. See it. Okay. So we open the fluid sim software, go to file, open a new page. So what is our aim? The sequence is A plus, B minus, A minus. There are two groups. So like earlier, we select a double acting cylinder. So now this double acting cylinder, double click and change all the name. So it's a D double acting cylinder 1. So use you can take A double acting cylinder A. Then configure this. Then actuating level A plus, A minus 0, 0. Then A plus 100. Okay. So you'll get anything you want to change means you can change external load or post profile or configuration you want to change this cushioning means you can remove the cushion. So now it will be very clear. Now you copy it, paste it here. So directly double click and change the view. Change the name to V. Okay. So now each cylinder we need each direction control valve. First we choose the direction control. Go to mechanical operator direction control, 5 by 2 you can choose. So choose a 5 by 2 direction control. Okay. So double click and change it double act direction control valve DC1. Then configure the value. I think it's correct only. Correct only. Here it is pneumatical operator. Both side pneumatic. Now spring return. Then you can go for copy, paste it here. Okay. So likewise we need 3 by 2 valve for limit switches. So you can go for 3 by 2 valve with push button. Click it and move it and rotate. Rotate to 70 degree. Double click and name it as LS1. Configure the value. I think these are all correct. So we have to go for mechanically roller operated with spring return. Now double click is A minus. Okay. So copy, copy and paste. You need double. So paste also one, also one, also one. So now we change the configuration. This one is A plus. This one is A minus. This one is plus. Okay. So now we have two groups. So two group lines here that. So for drawing the group line, you go to supply element, choose the compressor air supply, keep it there, copy, paste it like this. This is the pressure line. So now you can copy one more. We have paste, paste. Then we need a compressor, paste. Then we need a FR limit. Then we have two groups. So we have to go for one. So copy this, change it to group call group wall 1. Okay. So I think all components we choose. Any doubt in this? We have two cylinder, sequence A plus B plus, B minus A minus. It starts from last action. So we have to start from last action. Last action is A minus. So A minus. First you connect all the first group with the group line 1. A plus B plus. So A plus. So we have to connect the group line 1. First group A plus. So this is A plus. Then second group A plus. Similarly, it's also group 1. Okay. Group 1. Then another one will be there that receive. Okay. So these are all the circuits will receive the energy from group 1. Then A minus B minus. So all you have to keep it in from cylinder, sorry, line, pressure line 2. Similarly, this line, pressure line 2. This line, pressure line 2. Be connected. This one you have to connect from pressure line. This one you have to connect from pressure line 2. Now you have to connect all the so it's not a light one. You have to connect here. Yeah. Really, it's also not. Sorry, it's here to finish. This one you have to connect not with the first one because it is A minus. So you have to connect with the group line 2. Okay. Also this one. So you have to connect this one. Sorry. So you have to connect to the first side. So okay. Then this one you have to connect first. Okay. So now you connect this. You have to connect this A plus. So we are reaching next one is B plus. So from here you have to take signal to then after A plus you have to receive the signal and you have to change the group one. Okay, change the so wherever you are changing this signal, you have to go for changing the line with different color. Okay, with you can go for 3, then it will be anything. So it is, we are seeing the signal. Go for time properties, change the color, dotted line, or any line, whatever you want, you can keep it. Immediately it will get changed when what will happen? The changing means this one get activated, so retraction occurs. When you are getting the retraction, immediately that signal you have to send to the B minus, then A minus. See, double click, go for drawing properties, change it into color, then you dotted line, then you go for line. After this, A minus, then you have to go for B minus, A minus, A plus. So for that you have to change the group. So you have to go for changing the double click, drawing properties you go, color, okay, then double dotted line, then go for line 3. So now it is clearly understood. So now we have to connect the pressure line and get to. So likewise, copy it and get it. Right. Likewise here also. Yes. So I think all connections are ready. After connecting, what you have to do, you have to remove the compressor here. Otherwise, it will be always engaged. So now it is very clear. Now we can go for simulation. So once again I'll explain. We have a sequence of A plus, B plus, A minus, sorry, B minus, A minus. So we have two groups. So there is one group wall and four limit switches and two direction on the wall we are having. Okay. So then in this group wall, we are having a group wall one. Initially it takes group one. So immediately it get activated. So we are getting A plus. After A plus, you have to go for B plus. For that, we are activating DCV2. So immediately we are getting B plus. After B plus, you have to change the group. Then all immediately right side of the DCV2 get activated. So B minus we are getting. So that means this one is de-energized. This is energized. Understood? So immediately it reach LS3. So that signal we are taking and passing to next action B minus A minus. After A minus, that signal we have received the same group. Sorry, group wall left side. Okay. So now we can go for simulation. So go to home, execute, start. Enjoy this video with designing the cascading circuit. Usually, B minus. If note down and prepare yourself, you 2-3 times you practice it. It will be very easy to for this section. Okay. So now we have a, when while we are doing this, we come to a conclusion. To avoid the problem, we are using the trap signal. So that's why we are going for group. Always we design for a minimum number of groups. If more number of groups are there, more components will be there. That will extend your expenses. So it's very difficult to maintain or find out the sequence. So we have completed, the instructions are given, and we have designed and operated successfully the given sequence by using fluid software. Okay. So thank you. Thank you for your patient listen and your eagerness to learn this cascading circuit. Thank you.